Hello everyone. In this video, we're going to describe the end behavior of polynomial functions. Before we go over these examples right here, let's have the definition for degree and the sign of leading coefficient. We remember that degree is defined as the highest power or exponent of the variable in a polynomial expression. So if we look at this expression that we have right here, the exponents that we have are arranged 5, 4, 3, 2, 1. And so we can go ahead and say that if we look for the degree of this polynomial equation that we have right here, the highest power or exponent is 5. And when we describe the degree, it says that we're supposed to determine if it's odd or even. So our degree here is 5 and 5 is odd. So we can go ahead and say that the degree for this polynomial expression is odd. Again, our 5 here is the degree. On the other hand, if we say leading coefficient, this is defined as the coefficient of the highest power or the one with the highest exponent. So this represents our coefficient of the highest exponent or the coefficient of the variable with the highest exponent, which is negative. And if we say sign, we are talking about whether it's positive or negative. In this case right here, our leading coefficient has a negative sign. So we go ahead and write negative here. Okay, please remember that polynomials are usually written in decreasing order of powers or exponents. So pretty much all our exponents should be in decreasing order, just like how we did it in this example. So we started from 5, 4, 3, 2, 1. Now, if in any case you are given a polynomial expression or an equation where the exponents or powers are not arranged in decreasing order, we have to rearrange it in decreasing order so it's easier for us to determine the degree and the sign of the leading coefficient. So looking at this next rule right here, we remember that if we say even or odd, we are referring to the degree of the polynomial function or the polynomial expression. While if we talk about positive or negative, we're talking about the sign of the leading coefficient. So if we get an even degree and at the same time a positive leading coefficient, the end behavior of the graph, that means the two ends of the graph would both be directed upward. But if we get an even degree but a negative leading coefficient, both ends of the graph will be directed downward. If we get an odd degree and a positive leading coefficient, then the right side of the graph will be directed upward, while the left side of the graph will be directed downward. Now, if we have an odd degree and a negative leading coefficient, the left side of the graph will be directed upward and the right side will be directed downward. So this picture that we have here describes the end behavior of polynomial functions when we graph them. Okay, going back to these examples that we have right here, we're supposed to describe the degree and the sign of the leading coefficients of the following polynomial graphs. So let's start with the first one. So in this case right here, we're supposed to determine the degree for this. Since both ends of the graph are directed downward, this graph is even, negative. So I'm just gonna write negative for this. And so again, this graph has an even degree, and then at the same time, the sign of the leading coefficient is negative. Now let's look at the second one right here. The left end of the graph is directed downward and the right end is directed upward. So this is actually an odd degree. So the degree of this graph is odd, and the sign of leading coefficient, this is going down and going up. This tells us that the sign of the leading coefficient for this would be positive. And so I'm just gonna write positive right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, looking at this graph right here, the right side of the graph is directed up and then the left side is directed down. And so we can go ahead and say that this is odd positive. Okay, looking at the next example right here, both of the ends of the graph are directed upward. And so we can go ahead and say that this is an example of an even positive graph. So I'm going to go ahead and write even for the degree. And then the sign for this would be positive. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya!